everybody. We started the concept of annuities last time. Okay, how did you like it? There are two kinds of annuities. One is that, well, you keep depositing, so the balance in your account is increasing, right? So as a result, you are going to have a lump sum in the future. So you can call it a future value annuity or increasing annuity. The other one is that you deposit some lump sum in the beginning, okay, at present time, and your plan is that the money, the fund will support you for the next, let's say, 2 years or 3 years to go to graduate school. Okay, you don't want to work and you need to have some money available every month so that you pay rent or car payment, your insurance, whatever you need to. Okay, in that case, think about just the money in the bank. In the beginning, yeah, you have a certain amount, and then from that amount, what do? You withdraw, okay, to make your living expenses monthly, so let's say. So the amount in your account is what? Is decreasing. So we call it decreasing annuity, and look at the big amount goes into the bank in the present time, so we can call it a present value annuity also. So there are two things. You keep depositing and just you get the lump sum later. The other one is you deposit lump sum now, and then from there you are going to withdraw a certain amount, just same amount, at a regular interval of time. So every 2 weeks or every month or every 3 months, okay? Yes. So these two concepts, and we had two different formulas, okay? Well, today we are going to think about our ultimate purchase in your lifetime. For most people, what would be the largest purchase for you? For many, do not think about any business world, okay? You are not going to acquire a big company, no. You can have a big dream someday, but for just regular people, it's just your everyday life, not business life. Yeah, for most people, buying a car, right, okay? Or just some 5 years or 10 years, some people drive an old car, so it just is a different story for many people, because individually it's a different story. Well, then larger than car, that means, okay, you can buy a house, right? So for most people, buying a house would be the largest purchase. Okay, so just think about it. Most people go to bank. Who is going to buy a house with the cash? Well, there could be some, okay, but maybe I'm not one of them, or you may not be one of them. Okay, so let's think about a just pretty normal circumstances. What do? You go to the bank and tell them, I want to buy this house. And once the bank approves it, okay, it looks a good house and you have a good income, so I believe you can pay off the loan in someday. Okay, someday. Well, so the bank is going to give you money, big money, so that you can buy the house. And you are going to live in that house. So while you are living in the house, what do? Typically, you make a monthly payment. Okay? You can call it a house payment or a mortgage payment. Yes, the mortgage is the one that people use. Well, so someday you are going to pay off your big loan, right? Typically, people use a 30-year term. That means you are going to pay off the debt in 30-year period. That's a long, long time. Imagine if you buy a house at 30 years old, plus 30, you are going to be 60 years old once you finish the loan process, the whole thing. Yes, so that means it's like a very, very serious commitment, and therefore you need to understand the concept. Okay, so the vocabulary wise over here, amortization of loans. Amortization, that comes from French, that is death. Okay, so death of loans. How can you kill the death? I mean the debt. Well, that means what? You pay off the debt. So this amortization of loans, that means death of debts. That is, you are going to pay off debts. So we are going to look into just a big story, goes, you borrow money and you make a payment every month for the next 30 years. Yeah, next 30 years. You go to school for 12 years and you think that is a long time. Yeah, no, this is for 30 years. Okay? And at the end, you pay off. So you have no liability at the end. Okay. So what kind of annuity concept are we going to apply? There are two, increasing annuity and decreasing annuity. So it is important to see which side we are going to take. From your side point of view, you have a debt and you are going to make a payment. Okay? From bank side of the story is that what? The bank gives you big lump sum amount of money so that you can buy a house. So actually what are they doing? The bank is doing what? Put their money in your house, right? Not particularly for you. You live in there, so you are going to pay off. But for them, yes, they loan you money because of your house over there, okay? So take it this way. The bank is giving you lump sum, and as you make a payment, the bank is like what? Withdrawing money. You know what I mean? So it is going to be a decreasing annuity concept for the bank. So we are going to look at this amortization of loans that from the bank's point of view. So for the bank, they put lump sum in the beginning. So as you make a payment, that is supporting themselves. Yes, they receive this payment from many people. Yes, they are going to be their big income. All right. So your monthly payment, how you are going to compute monthly payment? That one is going to be the rent of decreasing annuity. Yeah. The most important thing for now over here is from the bank point of view, this annuity is a decreasing annuity. They put a big amount over there, and as you make a payment, the concept is like they withdraw, they support themselves over here. So the money will go down. At the end, it's going to be zero. Zero balance, that means you pay off the loan, house loan. How is it so far? Okay, so here we go. The most important concept of amortization of loans, it doesn't have to be like a house loan. For example, you just borrowed some $10,000 to update your computer system, or $20,000 to remodel your house or something, okay? So any kind of loans that the most important part is going to be what is your payment, okay? Typically that is monthly, but could be different, okay? This is the same as the rent of a decreasing annuity. Well, for us, it's easier to think about increasing annuity, okay? Because you just as a consumer, what we do, we rather just deposit little by little, and then at the end you are going to have some lump sum in the bank. But from bank side, this is a decreasing annuity, so your payment is the same as rent of decreasing annuity. So these words go in the blanks on the first page of lecture 21. Okay, so having said that, we need all those formulas for the decreasing annuity. So what is the most important formula? That is R is I over 1 minus 1 plus I to the negative n times P. And well, sometimes over here the P is the other way around, so 1 minus 1 plus I to the negative n over I times R. Okay, so we are going to use these two formulas. No more increasing annuity. So let's look at the first example. It's pretty simple, yes. Well, you see a blank chart in the bottom of page 95. I'm not going to do that, okay? So what I'm going to do over here is just monthly payment, okay? Right. So this is a scenario. Emma got a loan of $1,000 to obtain the computer system for her business. The interest rate is 12%, compounded monthly for 3 months. Very short-term loan, right? So principal over here is $1,000 and 12% compounded monthly. Compounded monthly. Yeah, I chose just 12%. It's kind of high, but you know, just I chose to just for make your computation easy for just 3 months. So let's summarize over here. This is P, principal, $1,000, 12%, that is R. So R is 0.12 once you convert to decimal. Monthly, therefore, M equals 12. For 3 months, you don't even go over 1 year. Okay, so you make 3 payments and then it's done. So this N equals 3. Yes, do not use the word that N equals M times T stuff, okay? It's just straightforward, N equals 3. So what is I over here? I equals R 0.12 divided by 12. That is 0.0. What is that? 0. I'm sorry, 0. 12%. So every month you pay 1% of interest. This is what it is saying. Okay? 12% for a whole year. Therefore, every month you pay 1% of interest. Okay. So, what is going to be Emma's monthly payment over here? So again, this is a loan, and you are going to pay, or she is going to pay off in 3 times. So what is her monthly payment? That is this R, rent. Okay? So let's plug into that. So that gives you I is 0.01, 1 minus 1 plus 0.01 to the what power? N is 3, so negative 3. Okay, and then times 1,000. So how did the calculator work for you? Did you find a nice way to work around? Yes, okay. I mean, this is a must. When you take the final exam is mostly on this chapter 10 part. I do not want, you don't want, okay, go back to all these probabilities and, you know, the other linear programming stuff, okay? And I understand the situation. This is a very, very unusual circumstances, and I'm not going to give you the just cumulative exam. So this part, chapter 10 part, is the very, very large portion of final exam, and you must feel comfortable with your calculator. So put this one on your calculator, see what happens. See what you get. I got $340.02. When I saw this, well, I thought it's pretty reasonable. Why did I think that? Because look at the big picture. How much is borrowed? $1,000. Okay, so this much is borrowed. you make a monthly payment of $340.02. How many times? 3 times. Okay? So how much is that? All together you pay $1,020.06. This is a total payment. Yeah, I want you to look at the big picture. $1,000 is borrowed. You make a payment 3 times, each time this amount. So all together, this is your total payment. This is pretty close to $1,000, correct? Okay. So how much interest you pay? Interest paid. Yeah. In this case, as I said, you are going to look at this loan problems from bank's point of view. So you pay interest, right? You do not earn interest. So, yeah, it is more, reasonable to say interest paid. How much is it? The difference between the total payment and the original loan amount. That is $20.06. Okay, so this is a total interest paid. All right, so this is good enough for this part, okay? Yeah, in the bottom, how much interest does Emma pay in 3 months? Well, just critical thinking. Yeah, this is how you think. So now, this one was just a baby warm-up problem, okay? Let's increase the loan amount and let's increase the length of this timeline. Okay. For today's lecture, the most important thing, that is, you are going to have rent. I'm going to keep writing rent of decreasing annuity. Annuity. That is your payment. Okay? So here we go. Example 2, mortgage. Yes. On December 31st, 1996. So 12/31/1996. A house was purchased with a buyer taking out 30-year, $180,000 mortgage at 6% interest compounded monthly. Okay, so how much money was borrowed to buy the house? Yeah, $180,000. Okay, at what percent? 6% compounded monthly. So that means for the borrower, yeah, we are going to make a payment on this loan monthly. Okay, you have to have the same timeline. So it was a long time ago, right? Oh, I forgot to say, this is T equals 30 years. Yeah, it was a long time ago. Probably this was what? Before you were born, right? Okay, most of you are about 20 years old or 19 years old. Yeah, this is before you were born. But adding 30 is what? Adding 30 is 2000. Wait a minute. 2016. No, 30 years, I'm sorry. 2026. Yeah, still 6 years to go to pay off this debt. Okay? So this is this a long time. So the most important question is calculate the amount of monthly payment. Okay? So imagine you or your parent borrow this money, and to live in that house you have to make this monthly payment. So what is that amount? Well, we call it mortgage payment or house payment. So let's compute that. Okay, that is in our language. So that is rent, correct? All right. So let's use the formula. That is, okay, here is R equals 0.06, M equals 12, and T equals 30. So what do we get? I equals 0.06 divided by 12. That is 0.005. So, in short, you pay 6% per year. So, if once you divide it into 12, that means you pay 0.5% per month. Okay, 0.5%. How many times you are going to make a payment? Oh, that is 12 times a year and for 30 years. So that means 360. So N equals 360. That means you are going to make 360 payments. That's what that is. So let's put in the on the formula. So I is this. 1 minus 1 plus I, 0.005 to the what power? Negative N, which is negative 360, and multiply by the principal, which is 180,000. 180,000. Yes. Okay, I will wait. I want you to compute yourself. All right, so that is, I'm doing it now. So what do you get? We get $1,079.19. This is monthly payment. Okay? So right under $1,100, you are going to pay this every month for the next 30 years. That's the concept. Okay? So I think the most important part is finding the monthly payment. The next one is calculate the amount applied to the interest in the first payment. This is a concept over here. This is a monthly payment. In other words, for the bank, yes, bank receives this, right? Bank receives this. And this amount will be split into two parts. The one part is going to be, yes, the bank have to make the interest. This is their income, correct? Okay. So, and this part, another part is going to the principal. In other words, when you make a payment of this amount, certain portion goes to the bank profit, which we call it interest, and the other part is to cancel your principal. Yeah, you have a big debt and you have to cancel this one out, okay, over time. So the certain portion goes to principal. So let's figure out how much it is going to go into. Each month, the different amount will be